Can you believe we're already on part 3 of the ellipse introduction? Remember, ellipses are conics, and the definition of an ellipse is the set of all points such that the sum of its distances from two fixed points is constant, which means this number right here doesn't change when I move this point around. You gotta be kidding me.
Oh my God. You gotta be kidding me. You gotta be kidding me.
No, I'm not kidding you. Today, we are graphing ellipses from standard form, which is fantastic, and finding the vertices, foci, and eccentricity from the graphs. Let's review parts 1 and 2 first. Remember, A occurs 6 times in the ellipse, and that's crazy. It's the distance from center to major axis endpoint, or from minor axis endpoint to focus. And remember, if there's 2 of them, it's the major axis. We call that 2A. This length right here, half the minor axis is B. It occurs twice. If you put them together, it's 2B. And the distance C is from center to focus. There is a Pythagorean relationship where A squared equals C squared plus B squared, which we've used a lot. We derived the equation of an ellipse and saw that A and B occur in it, which is fantastic. We looked at the eccentricity of an ellipse and saw that an ellipse closer to 1, or an eccentricity closer to 1, is flatter, and closer to 0 is more circular. At Socrative, if I ask for number 1, and I will, that's what I mean right there. And the answer is B, because the one closer to 0 is the one more circular. We saw the orbit of Earth is an ellipse, and it's pretty darn circular. And Pluto's is more flat. It has an eccentricity of 0.25. Horizontal ellipses have A under X, and vertical ellipses have A under Y. We have talked about that. We should know this answer right here is vertical because 100 is bigger than 40, and it's under Y, and the answer is A. We know that the horizontal ellipse here is choice A because 100 is bigger than 49, and it's under X. We need 3 things to write an ellipse in an equation. We need the center and half the major axis, which is A, and half the minor axis, which is B. We use this format many times now, that the X coordinate of the center is H and the Y coordinate of the center is K. And for horizontal and vertical, it's all the same thing. Pause the video and see if you can do that problem. You should be able to graph the foci with no problem and understand that the center is halfway between them. You need to make that calculation with the y coordinates to get the -7 right there. I'm sure you can do that. And we're graphing the minor axis endpoint here, and just repeat the distance over there to get an approximation of the other one. We could actually figure that out. That would allow us to sketch the ellipse. Keep in mind the ellipse is not as important as the right triangle, center, minor, focus, center, minor, focus. You have to keep telling yourself that, no major, please. And in the right triangle, center to focus is 6, center to minor is 8. We can do the Pythagorean theorem to find that A value, and it looks like 10 to me. And we want to go back and do the eccentricity is going to be 6 over 10. Remember, it's C over A, and it's 0.6. And when we write the equation, we have to pick the correct format. This one is not right because that's a horizontal format. We want the vertical format. Let's HK the center. Remember the center here, the 5 and -7 go in like that. And then let's put in A and B. A is 10, so 10 squared is 100. B is 6, so, B is 8. 8 squared is 64. Hey, let's stop all that reviewing stuff and get into today's lesson, which is really building on old stuff, and it's not even going to seem new, which doesn't that sound like mathematics? You really should be able to tell me the coordinates of the center. If you need to pause the video at any point, do that. The coordinates of the center are -6, -5. Let's go ahead and graph that. We are graphing, by the way. And you should be able to tell me the value of A. If A squared is equal to 100, then you know that A is equal to 10. Well, let's use that. You also know that this is a vertical ellipse because 100 is bigger than 9. So from the center, we're going to go up 10 spaces. And if you do that, you should know that you're at the point -6, +5. And that's a major axis endpoint. I probably at Socrative will ask you, what is one of the major axis endpoints? And you only have to tell me one. And it doesn't matter which one. Well, if we go up 10 to get one, we go down 10 to get one here. And then that coordinate should be -6, -15. just subtract 10 from the y coordinate. You can do that. You can tell me that b squared is 9. And if you can do that, you can tell me b is 3. That means we go right and left 3 from the center. And then we should be able to say that those minor axis endpoints are -3, -5, and -9, -5 here and here, which would allow us to sketch a graph of the ellipse, which we're doing that, but it's not as important as the right triangle in the ellipse. So let's get to that. We would need the right triangle to find the value of c. See if you can do that. We're going to need the foci. The foci are going to be about here. I'm just going to draw in one. And we don't want the 10 from there to there. We want the 10 to be from there to there, from focus to minor. We've seen that many times. Darn. And so we want the 10 right there. And then we can figure out that distance right there, the c value, by the Pythagorean theorem. And you should know that it's √91. You can come up with that. And then we would ask, well, what are the coordinates of the foci? Well, the coordinates are going to be irrational numbers. You can deal with that. See if you can write that down. So the foci are here and here. The distance here is √91. So we're just going up √91 from there. And then we're going down √91 from there. And so you just add it and subtract it. The way I really want you to write that is like this, where it's -5 plus √91 for the y coordinate, -5 minus √91 for the y coordinate. If you just have to make those decimals, I guess I will allow that. Let's see if we can do another problem. All right, guys, this is the last problem of the day, and that makes me awfully sad because I'm going to miss you when we're done. Pause the video and see if you can do 10a through g. If you can do that, you're a top hitter in the league. You can at least do 10a. The coordinates of the center are 1, -3. You know that. And you can find a. If a squared is 225, then a is 15. And we're going to go right and left 15 from the center. That just means you add 15 and subtract 15 to 1. Which you can do, and that would give us the coordinates of the major axis endpoints. And we kind of do the same thing for the minors. If b squared is 144, then b is 12, and then that means we're going to go up and down 12 from the center. You would add 12 to -3. You know you can do that. That's 9, and subtract 12 from -3. That would be -15. That gives us those coordinates. I will ask for this stuff. Now, to find the value of c, we need to put in a focus because the right triangle is center, minor, focus, center, minor, focus, center, minor, focus. You got to tell yourself that. No major, please. Then you do the Pythagorean theorem, and we realize that this distance right here is 9. And then we just go 9 to the left, 9 to the right from the center, which means we add and subtract 9 to the 1 and come up with these coordinates. Man, that's fantastic. I think we have one thing left, which is just the eccentricity. The eccentricity is c over a. So that is going to be 9 over 15, which is 0.6. Remember, it's 9 here over 15, c over a, to give you that fraction. Guys, I've had so much fun today, and I can't wait to part 4 of the ellipses.